Okay, this is a kind of a unusual paper in the sense that it is just looking at fossil fuel reserves and resources, and arguing that if we can find a way to do carbon capture and sequestration to match the emissions of burning these fossil fuels, then we could keep going with them for a long time. Well, not many people will fall for this argument, I suspect, considering all the focus on decarbonizing and so on, because if considering the energy density of these fossil fuels and the fact that the entire system is built for fossil fuels as we stand today in 2022, it would be great if we can continue and there is enough fossil fuel available, but we can just magically take out all the CO2 that they are going to emit when we burn them. Of course, it doesn't talk about mercury and PM 2.5 that would come from burning things like coal and all the other health impacts, but kind of an interesting exercise nonetheless, considering that we are anyway relying or hoping to rely on carbon capture and sequestration and negative emission technologies in our global warming targets. And also this paper includes Simon Tett, who's a climate scientist and a forecaster, an El Nino forecaster, who when he was at ECMWF, I don't know where he is now, and Andreas Oschlies, who's I think is in Kiel, and is a ocean carbon cycle scientist. So this is just one figure in this paper, so I'm going to just go through it. Remember that reserves are those that are considered producible, estimates of producible fossil fuels, and resources are kind of optimistic geologists expect theoretical estimations which can be orders of magnitudes higher than the reserves. Okay, so here are the emissions from supply, and here are the storage options. So let's read the caption first to make sure we don't miss anything. Sizes of fossil fuel carbon supply, reserves and resources, and potential carbon stores divided between temporary, so less than 1,000 years, which is definitely an intergenerational ethical problem, and permanent geologic time scales, so greater than 100,000 years in gigaton CO2. Gradient shading indicates relative degree of establishment as a carbon supply or potential large-scale carbon CO2 store. For example, oil and gas reserves are well quantified. Large-scale storage in saline aquifers is well established. Basalts and ocean water have large theoretical storage potential but are unestablished, indicated by a question mark. Oil and gas reserves and resources are both a fossil carbon supply and a carbon store, so enhanced recovery and other options of using exhausted oil wells, for example. Coal seams could be used to store CO2 if not mined, and gas hydrates might be harvestable through swapping in of CO2, so enhanced recovery approach again. Natural carbon cycle would slowly transfer small amounts of the carbon content of temporary storage into permanent storage, which are shown with dashed arrows here. But most of the their carbon content has the potential to be equilibrated with the atmosphere within the time scale of ocean turnover, which you can think of as combination of biological and solubility pumps, of course with warming and committed warming, especially in terms of the warming due to the CO2 that has already been accumulated, unless that is also taken out, will affect ocean turnover of carbon as well. Dotted vertical lines indicate CO2 emissions budget associated with 2 degrees C, 4 degrees C, and 6 degrees C climate warming. We are really worried about going beyond 2 degrees C, but 4 degrees C and 6 degrees C will probably not be entertained by most people, even though we don't know for sure what happens if we do hit those in terms of all the impacts, because there will be winners and losers. For example, if high latitudes become snow free and become agricultural lands, then Siberia could be a rich wheat field, and Arctic would yield a lot of fossil fuels to continue this sequestration and offset kind of business that's being considered here. So you can look at the emissions. So supply, all these are in gigaton CO2 in this direction and in that direction. So this is storage and this is supply. To present what we have emitted in terms of gigatons, CO2 emissions budget to 2 degrees C, to 4 degrees C and 6 degrees C. They are way out here in the range of, we go from 1000 gigatons to order of magnitude larger at 10,000 gigatons. So resources in terms of producible, there is coal, which has a significant amount, which will easily take us just by itself beyond 2 degrees C. But what if it is unmined? Then it can be used for storage. Oil reserves have some room if we continue to burn them, but again, if we they can be used for storage as well, as we already know from enhanced oil recovery, where we are putting in more CO2 than taking out as oil. Similarly for gas, if we consider resources, coal is massive, goes from just over 1000 gigatons to almost this is a non-linear scale here, so you have to be careful. So to almost more than 50,000 gigatons. Similarly for gas hydrates and oil and gas, but both also have storage potential on this side, and the storage needed for 2 degrees C, 4 degrees C and 6 degrees C targets are shown here. So these are obviously enough in that sense of the potential for storage. Deep coal seams unknown. Depleted oil wells can provide plenty of storage. Depleted gas, so this is different than these, where enhanced recovery and other methods are used for storing carbon. Saline aquifers, so there are some unknowns there, as we saw. Basalts, so these are permanent stores greater than 100,000 years, and these are temporary stores less than 1,000 years. So seabed sediments, enhanced weathering, and so on are here. So you can see that these, at least in terms of reserves, potentially can be managed by storing if full storage potential is accomplished. And then we have here afforestation, biochar, and ocean waters providing temporary storage of less than or equal to 1,000 years. So the vertical dotted lines, as you remember here, let me make it, the dotted vertical lines indicate CO2 emissions budget associated with 2 degrees C, 4 degrees C and 6 degrees C climate warming. Okay, so that's what we would need in terms of storage, let's say from afforestation, biochar, and CDR, ocean CDR as it's called, carbon dioxide removal in the ocean. So again, it's just interesting that people are saying, what if we could find a way to store away carbon? Can we continue to burn fossil fuels, since the system is already forcing us to do that anyway, what we called as carbon trap before, where no matter what we do, we are going to emit CO2 right now in the current system, with the food we consume, travel mode, clothes we buy, how we travel, and what we use for work in terms of data and software and storage and all those things. So leaving the system as is would obviously be very easy, And if we could actually come up with storage, then this is kind of a dream scenario of a trillion-ton world where fossil fuels can continue for a while. Okay, so I just wanted to leave it there.